Hello guys, I'm having a hard time getting the picture right on this. This is just like immensely frustrating. So, but that's sort of like where my day has been. I've been trying to get stuff uploaded on my computer. My computer is not impressed with doing anything that I want it to do. Keeps crashing on me. My husband says it may be point where I'm going to need to consider replacing it. Lucky poop. So we'll see what I can do. Let's look at Chapter 9. Chapter 9 is where we're going to be talking about in chemistry. 1. Polyatomic ions in molecular geometry. This is where we're going to be seeing the three-dimensional shape of an atom or of a molecule. What you did in Chapter 8 with the Lewis structures is you were able to come up with a two-dimensional picture, flat surface picture of what a molecule looks like. But we need to be able to see these molecules in 3 dimensions so we see how they fit together. So what we do with this molecular geometry is picture what these things look like. If you're not really comfortable with Lewis structures, you need to make sure that you get comfortable with those, because that is the basis for which we're able to do the geometry of a molecule. So let's look at one for an example as a review. I'm looking back here at page number 272, and it tells us to determine the Lewis structure for CH2O. So this is on your own problem number 8.11. 8.11 on your own. Let's see, yeah, I can see that. Okay, determine the Lewis structure for CH2O. What they told us to do was go ahead and just write out each element, each atom individually. We have a C, and we have 2 H's, and we have an O. And we want to find out how many electrons there are in its outer energy level. So if you look at C, it's in column 4, O is in column 6, and H is in column 1. So there are 4 electrons in the outer energy level of carbon, 4 valence electrons. There's 1 valence electron for hydrogen, and there are 6 valence electrons that are attached to this molecule of oxygen here. So we have 1, 2, 3, 4, 5, 6. And what we want to do is put the atom that needs to gain the greatest number of electrons in the middle of our picture. I want to go ahead and pull over here to make sure that I have this up to the solutions to make sure that I'm doing this correctly. Now it would look, well, when you look at first glance, you might think that you need to put the hydrogen in the middle, because it looks like, you know, if the ideal state for an atom is to have 8 electrons, 8 valence electrons at its outer energy level, well, it looks like hydrogen would need 7, except you remember that hydrogen wants to make itself like helium. Helium only has 2 electrons in its outer shell. So helium is looking for 1 electron. Oxygen has 6, so it needs 2 electrons. Carbon, however, only has 4, so it is searching for 4 electrons. So let me see. Where are you going to be able to see me? You're going to be able to see me right here. Okay. So if we have carbon right here in the middle, we have carbon, we have a hydrogen that just needs one. So how about if we put a hydrogen here, and we put a hydrogen here. Does that look right? Is hydrogen happy now? Hydrogen has 2 valence electrons, it's happy. This hydrogen has 2 valence electrons, and it is happy as well. But let's see what I want to do. Thinking that I'm going to have a double bond here, let me move this hydrogen right down here. And what the book reminds us is, since these electrons are continually moving within its orbitals, we can draw our Lewis structures in a number of different ways, because we're just taking a snapshot of where that electron might be at some particular point in time. So now the hydrogen's happy, it has 2. Hydrogen happy is, it has 2. The carbon is happier than it was before, because it has 6, but you have to have 8 valence electrons for carbon. Oxygen is not happy either, because it has 6. Now, let's see, what could we do? Well, carbon and oxygen, if you look at these, carbon and oxygen are both nonmetals, but you've got 6 here with their nonmetals and metals. Yes, they're both nonmetals, but with both of them having 6 electrons around them now, they're not going to be very willing to share, right? Because remember that an ionic bond is only between a metal and a nonmetal. Since we have not a metal and a nonmetal, we're going to have a covalent bond. A covalent bond is one where they're sharing. Look at this. What if we put oxygen down here, right next to our carbon? And I'm not doing as articulate a job as I like to with this, but I hope you'll be able to understand what I'm doing. I have oxygen down here, and I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We're sharing this bond right here with carbon. Now, I still have an unpaired electron here. I have an unpaired electron here. What if we move this down from the top of the oxygen and we move this other carbon electron down here? Does that make everybody happy? Well, let's see. 2 electrons here, 2 electrons here, 8 electrons spinning around the carbon, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons spinning around the oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Now what we need to do is we're looking for these bonds. I want to see. We're sharing these electrons right here. The hydrogen isn't giving one to the carbon, because if it gave it to it, it wouldn't have enough. It has to have those 2 electrons. So anytime you have a shared pair of electrons, that's a covalent bond, and you replace that with a dash. So here we have 1 pair of shared electrons. So we have a covalent bond between this hydrogen and the carbon. We have another pair of shared electrons, and we have a covalent bond between those two, between the C and the H. Now, how many pairs do we have of shared electrons? Yeah, we've got 2 pairs here. So we have 2 lines, which is a double bond. And then we have a pair of electrons. 1 pair here, 1 pair here. Let's see if we're correct. We've got a covalent bond, so we have 2. Covalent bond, we have 2. 2, 4, 6, 8. So we have the 8 electrons around carbon. We have 2 covalent bonds and 2 pairs of unpaired electrons. So this is our complete Lewis structure. Let's see. Let me look and see what they say. I'm thinking that I just skipped a line in my solutions. C, single bond, double bond, 2 pairs of electrons. This right here is the complete Lewis structure for CH2O. I don't know what that name is, but I do want to go ahead and write this one up over here to the side. I'm trying to figure out where I can do it. Okay, so we have C, H, H with a double bond to O and 2 pairs of electrons. Let's see if that all shows up. Yep, that all shows up. Now, I want to go ahead and move on. This was 8.11 on your own problem. Now let's go ahead and move into a discussion where we're beginning with the first part of Module 9. But I've decided, since I'm having so many issues with making these ultra-long videos that are so boring, and also I'm having issues with my computer equipment, what I'm going to do now is just go ahead and erase this and try and upload this one tiny little teaching video that's a review of Lewis structures from Chapter 8. I am going to leave this complete Lewis structure up here because we're going to use this when I begin Chapter 9. So I'm going to go ahead and shut this off.